Good morning everyone, I'm Tony and today I'll be presenting Assembly Programming Language. Assembly language is a low-level programming language that provides a direct interface with a computer's instruction set and memory. It allows the fine-grained control over the hardware, making it a crucial tool for system programming, device driver development, and real-time application. So without further ado, let's get started. Assembly, a low-level programming language designed to simplify the instructions fed in the computer CPU. In other words, it's a human-readable abstraction on the top of machine code, so programmers don't have to manually count ones and zeros. The first assembly language was created by Kathleen Booth in 1947 for the all-purpose electronic computer. Over the next decade, it evolved into many different formats to power the supercomputers of the day like the IBM 7090, which had a $20 million price tag in today's dollars writing code. And assembly was standard until the emergence of high-level languages like Fortran. Few years later, however, assembly is still used today for direct access to bare metal hardware and to address low-level performance issues, often on device drivers and embedded systems. And it's also used to run native software and a web browser via WebAssembly. What's tricky is that each assembly language only works on a specific CPU architecture, like ARM for Apple Silicon and Raspberry Pi or x86 for Intel chips. To get started, you will first need an assembler like NetWhite assembler for 86 trips. In assembly, program is divided into three sections. The section contains the actual logic for the program by convention. It contains an entry point called start, which is where the code will start executing. Next, we have the block starting symbols action, which contains variables that might change rather life cycle of the out, and finally the data section is where we can initialize constants or data that does not change to declare a closure. Like a string, we start with a label, then use db for define by to place the hello word string into the memory by itself. It doesn't do anything and to print it to the standard output. We will also need to when we can use equate to convert a symbol into a constant. The $sign must track the current position from the hello label, providing the length of the string, and now these constants can be referenced from the start label. In the main program, each line of code contains an instruction along with one or more operands, and there are hundreds of instructions built into the language. Now to perform operation quickly, the CPU has a limited number of registers, which are like 64-bit chunks of memory built directly into the CPU. Instead of the RAM, you can insert data into a register with the move instruction and by providing operands for the register or name. In the data to store there, in this case number 1 is used because it corresponds to the system right in Linux. Next, we need to tell the system works right, in which case we'll move 1 into the register, which is almost done, but we'll get a segmentation fault. If we try to run it at this point, update the ROX register with a 64 system exit and provide an error could have 0 for success. Now use the assembler to compile or assemble your code into an object file. To use the linker to convert it into the final executable. This has been assembly language in 100 seconds. In summary, assembly programming provides a powerful tool to manipulate the underlying hardware, but it requires a deeper understanding of the system and lot of patience and attention to detail. Thank you for watching.